Hi, I'm Celine. Today I'm going to be doing a paper 2 topic 5 question. Due to copyright reasons, we cannot show the question, but you can find it using this code. Topic 5 is about energetics and thermochemistry. Okay, so in an experiment to measure the enthalpy change of combustion of ethanol, the student heated a copper calorimeter containing 100 centimeters cubed of water with a spirit lamp and collected the following data. The initial temperature of water was 20 degrees Celsius, the final temperature of water was 55 degrees Celsius, the mass of ethanol burned was 1.78 grams, and the density of water was 1 gram per centimeter cubed. The first question asks us to use the data to calculate the heat evolved when the ethanol was combusted. To find that, we need to use the equation Q equals mc delta T, where Q is the energy transferred or the heat, M is the mass of water, specific heat capacity is just the heat capacity of the substance, and delta T is the change in temperature. Since delta T is the change in temperature, it can either be in Celsius or Kelvin, so there are no unit conversions needed there. This question in specific does not give us the mass directly, however, we know that mass equals density times volume. We have the density of water, which is 1 gram per centimeter cubed, and we have the volume of water, which is 100 centimeters cubed. So we substitute those in the place of density and volume, and we get that the mass is 100 grams. The specific heat capacity for water is just 4.18, and that's a very known fact. And then the change in temperature, we will get the final temperature and subtract it from the initial temperature and get 35. Then we multiply these numbers, 100 times 4.18 times 35. And since this is a paper 2 question, you are allowed to use your calculator. And you're gonna get 14.6 kilojoules or 14,630 joules. And either of these answers will be correct, or if you want to reduce your significant figures, you can just have it as 14,600 joules with only 3 significant figures. But either answer is accepted by the IB. Also, you need to be particularly careful to not use the mass of ethanol in this question or anything related to ethanol. Here we are simply talking about water and its temperature change, and no figures regarding ethanol should be used. Otherwise, that's just going to make your calculations inaccurate. When you're using Q equals mc delta T, you need to make sure that all of your numbers are according to one thing, which is in this case water. Okay, so question 2 asks us to calculate the enthalpy change of combustion per mole of ethanol. And to do that, there are 2 parts that we need to do and 2 equations that we need to use. So first, to get the enthalpy change of combustion per mole of ethanol, we need to know how many moles there are. And to get the number of moles, we're going to need to get the mass of ethanol, which we are given, 1.78 grams. And we're going to need to get the molar mass of ethanol, which we can easily find using the periodic table. And it is just 46.08. And we divide 1.78 by 46.08. And we're going to get that we have 0.0386 moles. Afterwards, to get the enthalpy change, we need to do delta H equals negative Q, because this reaction is exothermic. Combustion is always exothermic, which means that heat is released and there is a loss in the total heat content of the system. So the total heat content must decrease, and if it decreases, the final value would be less than the initial value, giving us a negative number for the change in enthalpy. So we substitute into Q the value we got for question 1, which is 14.6 kilojoules, because that is the heat energy, and we divide that by the number of moles. And that would give us an enthalpy change of negative 378 kilojoules per mole. And the IB allows a certain range in case, for example, you put in the moles at 0.037 or you do any kind of rounding. So you have a range to a certain extent to get the question right. And I just want you to note the triangle on the side, which is one we learned in topic 1. Number of moles is mass over molar mass, and that's what we did in this question. The third question in the final part asks us why it is not the same value as the data booklet. So an explanation for that would be heat loss to surroundings. If the person conducting the experiment does not insulate the apparatus and use a lid, their value will be different than the one in the data booklet, because the one in the data booklet does not account for such matters. And another explanation would be incomplete combustion, where black salt is produced. And the way to prevent that is to use pure oxygen, but that is not possible for most conductors of the experiment. And then heat absorbed by the calorimeter. The copper beaker gets hot and it starts absorbing heat, and this can also change the value. So a way to prevent it would be including the heat capacity of copper in calculations. And this is one that was not on the mark scheme for the question, but the accuracy of the balance and thermometer. And the way to prevent that is to include uncertainty in your calculations, which we read to plus or minus 0.1 for the balance and plus or minus 0.01 for the thermometer.